Welcome to a lesson with Dr. Powell. Let's talk about how we can find the area of a region in the xy plane by using a double integral. Now, double integrals calculate volume. Now, how can that be? Well, they calculate the volume underneath the surface. What if that surface simply were z equals 1? Then we'd be thinking of a height of 1. And if we want to find the volume of underneath this function with a height of 1, think about what we have. We have kind of a shape, kind of looks like something like this. And so we kind of have the base looking like the top. And to find the volume, it simply amounts to finding the area of the base. So area of base multiplied to the height. Suppose the height is 1. Then the volume, at least numerically, is equal to the area of the base. So to compute area of the base, we can do a double integral where we throw in the surface f of xy equals 1. So for instance, what if we had the following? What if we had something like function y equals 4 minus x squared? Maybe we also have the function, and let's see, this is the x-axis. There we go, there's the y-axis. And suppose that we have this function here, which is y equals 2 minus x. All right, let's see if we can find the area between these two curves by using a double integral. All right, so this is a region, the xy plane, call that region R. So our goal is to find the double integral of under the surface 1 dx dy for a particular region R. Okay, so in computing this, perhaps we need to get these coordinates, especially if we want to do things in terms of maybe x would be nice for constants, because then we just have two functions to go between. If we were going y, then think what would be happening here. We'd have to kind of switch up what's happening. So for this particular thing, it'd be nice to have to go dx starting from this bound and going to that bound. Let's figure out what this one is right here. This one is 2. You can see just by plugging in 2, you'd notice they both equal that y value of 0. So they both go to that point. What about over here? Okay, so we have to set those equal to each other. 4 minus x squared is equal to 2 minus x, and solve. All right, so let's move the x squared to the other side and the 4 to the other side to get a negative 2. And we have negative x. Okay, so that's equaling 0. And now this actually factors x minus 2, and we're going to have an x plus 1 as well. So that means that that point of intersection is going to happen at negative 1. You can check that. You plug in negative 1, you get 3 here and 3 there. That's perfect. So there's our intersection point. So let's go from negative 1 up until 2 for x, and then at a position y somewhere in here. Let's just kind of look, see what we got here. Right. So at a certain position for x, we need bounds in y. They go from the bottom function to the top function here. So they're going to go from 2 minus x, because that's the y value right there, all the way up to 4 minus x squared. It's the y value up there, right there for that particular x value. And that'll be a dy integral, and our function is 1. Okay, so we've just set out a double integral to compute the area. Now, we didn't have to do this. We could just do the technique that we have from Calc 1, which we'll actually see is equivalent to what we're doing here. So let's go for it and see. I'll do the calculations up here. All right, so the inner integral right here, I mean, this is just y. The antiderivative of 1 is just y here, and you're plugging in 4 minus x squared and then subtracting 2 minus x. Now notice when you do that, you end up simply just getting 4 minus x squared minus quantity 2 minus x, which is exactly what you would do if you're just subtracting the two y values of the two curves when you're integrating, finding the area between two curves. It's the exact same setup, but this just illustrates that it can be thought of as a double integral as well. So from -1 to 2 here, and then we can just go for it and compute this. All right. So we end up having, 4 minus 2 is just 2, and then we get minus x squared plus x. All right, so 4 minus 2 is 2, minus x squared, and then plus x. Okay, so we need to integrate this still. So that would be 2x minus x cubed over 3 plus x squared over 2, evaluated from -1 up until 2. Okay, so we put 2 in here, and we end up getting 4 minus 8/3 plus 4 over 2, which is 2. And then we subtract off what happens when we plug in -1. So we end up getting, okay, so we plug in -1 into this, we get -2. I'll just write it out like that. Think of a negative right there so we can see what we're doing. Put the -1 in here, we get plus 1/3. And then we plug it in here, we get plus 1/2. Okay, so total we end up getting, let's see, so 4 and 2 is 6, and -8/3 and minus 1/3 is -3. And then we see we get 2 minus 1/2 is just 3/2. So we end up getting 3 plus 3/2, which is 4.5. Right, 3 plus 3/2, or which is 9/2. So it looks like our volume of this, or the area of this region right here, is just simply 9/2, and we did it using a double integral. Thanks for watching.